Welcome friends. In today's lecture of metrology, we are going to study angular measurement. In previous lecture, we have studied the linear measurement methods and now we will start with the angular measurement methods. First instrument used for angular measurement is sine bar. Here in this figure you can see the green colored box which looks like a vehicle is nothing but a sine bar. Actually, we will be aware and known the length of this sine bar. Here it is shown by capital L, and the hash portion is the or component for which we have to measure the angle or inclination. Here these slip gauges are present on the right side. I can show you on the screen. This is the slip gauge, right? If you can see it properly. This distance AC will be known. Just only this much bar along with these rollers is known as sine bar. Now our task is to find the inclination of this machine component or any component. So by using Pythagoras theorem, we will find this inclination as the height of the slip gauges will be known to us because we ourselves will be arranging these slip gauges one over each other. So as we know this length L and this height let us say BC, right? You can even measure from this point to this point and height up to this slip gauge, so that exactly you will get the height which is the height of the slip gauge. No need to consider these rollers then. If you are measuring from here, that is the contact point of roller and surface. Also here the contact point of roller and the slip gauge. So by using the trigonometry, you will know the value of this angle theta. This angle made by line AC and AB will be the angle theta. So you know that sine theta is nothing but the opposite upon hypotenuse, length of the opposite side of a right angle triangle divided by the length of the hypotenuse. So you have got the angle. Now important note is that sine bar is specified by the distance between the centers of two rollers. That means the length of the sine bar is its specification. For different heights we will use the different sizes of the sine bar, but one drawback of this sine bar is that it cannot be used for convenient measuring of angles more than 60 degree because slip gauge adjustment problem, because there is a limit to the slip gauges. You know that in slip gauges box a particular height can be achieved only. So sine bar can only measure up to conveniently up to 60 degree Celsius. Sorry, 60 degree, not Celsius. The misalignment of workpiece with sine bar may sometimes introduce considerable errors. So you have to be more careful while measuring and arranging the slip gauges to find the angular measurement with the help of sine bar. This is second instrument known as Bevel Protector. It is very similar to our protector in our compass box of schools. You may have earlier used it. You just have to keep your workpiece, this hash portion, red colored hash portion is nothing but our component. By placing it on this horizontal surface, let us say, and the probe like structure, this blue color stick, you have to match with the inclined surface of the component. Then the circular scale on this protector will give the measurement in degrees. That will be the inclination or angle made by this inclined surface with the horizontal. Let us here in this example it is making 30 degrees. 30 degree it is making. Let's consider it. The third one is tri-square. This is actually used to measure the right angle triangle. If two surfaces are at right angle triangle or not, it can be found out by this tri-square. You may have seen it while using in your workshop in the carpentry section, or even you may have seen it in the construction sites of cement work or RCC structures. Here in this figure you can see there is little what I can say irregularity here at the corner. Look at the blue colored component and this red color is our tri-square. If I will pass a light from one side, let us say from this side, if there is irregularity, if this surfaces of the tri-square and the machine component are not facing exactly or not matching exactly, then the light which I am passing from one side will be visible from the another side. This is the way it is used. It is used to just whether the surface is at right angle triangle or not. Before going to study thread measurement, we will see don't worry, we will start thread measurement and then in continuation we will see few examples. Thread measurement, you can see here, let us say in this figure you can see it is a screw thread line. Let us say this diagram is showing a screw thread. So if you want to find the pitch diameter, then you have to use a wire method. There are different types of wire methods, which we are going to see is 3-wire method. And measure diameter you can easily measure with the help of micrometer. In yesterday's lecture or previous lecture, I have taught you how to use this micrometer for linear measurement. Now, pitch can be measured with the help of screw pitch gauge or pitch measuring machine is also there. And the thread from just by looking at the threads, and if the threads are very small and it is unable to identify whether the shape of thread is V shape or acme, then we will use the optical projector. Like our cinema hall, if we will throw a rays of light or flash a light on a particular component, then we will see the shadow on the another surface. Let us say this is my hand and I am flashing light on this hand, then there will be shadow of my hand on the another surface which will be behind this hand. So by looking at that shadow, that means the projected figure, we can find whether this thread form is a acme or V thread or square thread. These are finally this arrangement will be useful for finding the pitch diameter. Here one wire is kept on the upper surface of the thread, and on the lower surfaces of the threads there are again two similar wires having same diameter are kept, and this complete assembly is measured with the help of micrometer. This is the spindle of micrometer, and lower one is the anvil of the micrometer. Now we will see what are the designations. The outer diameter of the thread which we will measure by micrometer, D2 is nothing but the major diameter, whereas the imaginary diameter passing through the trough or the value of the threads is D1, known as minor diameter, and pitch diameter will be somewhere here. In this figure you can see dP stands for the pitch diameter. P is the pitch, that is the distance between two successive threads. Now we will start our wire thread method or three wire method for the measurement of the thread. So this distance W is given by dP, that is the pitch diameter, plus d means the diameter of wire, small d, 1 plus cosec alpha by 2 bracket complete minus p by 2 cot alpha by 2. Alpha is the thread angle, that is angle between the adjacent flanks of two threads. Let us say this is one thread, one flank, and this is another flank. Then angle made by these two adjacent flanks of this thread 1 and thread 2 is nothing but the thread angle. For metric method threads, or by metric thread method, V threads, that is alpha having 60 degree. Then and only in metric method or metric thread we will call the thread as a V thread if alpha is equal to 60 degree. For different threads there is a different alpha value, let us say for acme and square thread, right? Then how we will decide the diameter of this wire, and that diameter will be called as the best wire size. This will be equal to D equal to P by 2 sec alpha by 2. We know these values, so we will put these values and get the required diameter of wire for three wire method, which is used for the thread measurement. Right. Now we'll start the surface roughness measurement or surface measurement. Here you can see there is a flat surface, let us say, and smooth. Actually in practice it will not be there. There will be always some irregularity, but for understanding I have drawn it. Another is smooth and wavy surface, and third one is the rough surface. Real surface are rarely so flat or so smooth, but most commonly a combination of two. It will be combination of smooth and flat, or rough surface or wavy surface. Better the surface quality, longer will be the life. How? And better will be the performance of component. How can I say that? You know that if surface finish is there, the quality is, let us say, smooth surface is there, there will be lesser notches, lesser irregularities, which will reduce the chances of failure. Because if there is a notch or roughness, then there will be a notch propagation or crack propagation will occur at the notch. So there will be lesser fatigue life. I have already discussed in detail these things in previous lectures of machine design. You can watch those videos in the playlist given below. Right. Now important terms are the roughness height. It is the parameter by which generally the surface finish is indicated. There are different methods of indicating this surface roughness. We will also see those. Roughness width. It is the distance between successive peaks and valleys. Right. In the figure here you can see this is the roughness width. This one valley and this is another valley. The distance between these adjacent valleys is the roughness width. It may be between the distance between the two adjacent peaks or valleys or troughs. Roughness width cutoff. That means the maximum width. Roughness width, that is the cutoff value for the roughness width. Here you can see, let us say this is the maximum width is there in this complete surface, so we will call it as the roughness width cutoff. And here you can see the height, roughness height, the amplitude, maximum amplitude, let us say, of this surface roughness is the roughness height. So waviness is the surface irregularity that has a greater spacing. Spacing is also known as width than that of the roughness width. If there is a maximum irregularity or width than the roughness width, then such portion is called waviness. Here you can see, if the width is increased, the surface, we can say that it is having a waviness. Lay direction. It is the direction of predominant surface pattern produced on the workpiece by the tool marks. You know that if you have done practicals in your workshop, then a tool will leave some tool marks on the surface. If you are doing a facing operation, you can see the circular shapes are present on the on the workpiece. That is called the lay direction. It is different for different machining operations. We will see one by one. There are symbols also. You know that the surface finish is inversely proportional to the roughness height. More the roughness height, then lesser will be the surface finish. Here, different lay directions. If such, this is the symbol of roughness only. Square root sign is nothing but the symbol of roughness, and the inside shape gives the direction of lay direction. If these parallel lines are there, horizontal parallel lines, it is called parallel lay. It is seen in shaping and planing operation. Whereas if it vertical parallel lines are there, then it is called a perpendicular lay. It is also seen in shaping and planing operation. Now, such knurling type or cross shape is given. X is denotation for this X symbol is used to denote this. This is seen in honing and knurling operations. Honing, you may see it in the machining of a cylinder of a IC engine for giving smoothness and proper shape to the inside diameter of the IC engine cylinder. Honing is done. Then you may see such type of knurling type of small texture will be there. Not exactly knurling. Knurling have very large depth or thickness. And then if there is a regular shape is shown, then it is a multidimensional lay, not a parallel or perpendicular or honing type or knurling type. Then which is seen in grinding operations, lapping, shape finishing operations. It is shown by a symbol M. And as I have told you, discuss the example about the facing operation. There you can see exactly such type of shape on the face of the workpiece, and it is denoted by symbol C. These are the different symbols for the lay direction. Now this is the standard method for showing the roughness values, exact roughness values. On this vertical side, there will be the maximum and minimum roughness values. At the lower side, there will be minimum roughness, and at the upper side, there will be maximum roughness height. Both these are height, whereas on the horizontal surface at the top, there will be a waviness values. here maximum waviness width, or it is also called as maximum waviness spacing, right? And this is the symbol of lay, that is lay direction. It may be different. Now, important surface finish, how it is represented. This is the representation of the surface finish, inverted triangle. Before starting the method of determining surface finish, we will see one MCQ. Here it is. The surface roughness is represented by, options are ABCD, R equal to 10 micrometer, B is perpendicular sine under root, in the under root, this triangle, then D is under root sine with 6 as a value of roughness height. You know, this you may confuse it with this option C. Actual symbol is the inverted triangle, right? And it is asking the surface roughness, right? And that is exactly shown by this symbol. So we have seen that on this vertical side there will be a surface roughness value, right? This is the lay direction. Option B is showing the lay direction, right? So only option D is the correct. So better we will discuss this method of determining the surface roughness in next lecture. We are done with the angular measurement and thread measurement. We will discuss this method of determining surface roughness, because these are three methods: centerline average method, or arithmetic mean roughness, or stylus equipment is second, and interferometry. This interferometry I will discuss in very detail. So we'll start this surface roughness measurement methods in the next lecture. Thank you for watching. If you have any doubt, you can ask in comment box. Thank you for watching. Keep us following our channel by sharing, liking, and subscribing to our channel. Thank you very much. Signing off for the day.